Hi everyone. We are week 4 and we just started frame relay. We finished chapter 3 point to point and we're just getting started here, and we're right on track. Actually, we're a little bit ahead. So frame relay is a packet switched method of sending information through the cloud. You have a frame relay switch at the edge, and then we have the local loop that connects our DTE equipment with the frame relay switch. There's probably some data communications equipment in between there, and your local loop, you pay for it based on the bandwidth. So we have a local loop here at the other location. In this scenario, we said this local loop was like 10 million bits per second, and this one was 5, and then we created one up here that's also 5. Frame relay allows us to create a permanent virtual circuit. There's such thing as a switched virtual circuit, but it's a permanent virtual circuit. So on each end, for example over here, they get a DELC number. That DELC number connects into this frame relay switch and connects it to a particular virtual circuit. So in the case of this router here, this router would have 2 DELCs. You could have another one that would connect to here. So that traffic, then that permanent virtual circuit connects this DELC. The DELCs are local. They have local significance. So they get from this router to this switch, and this switch sees the DELC and it knows which circuit to put it on. The DELC over here has local significance. It gets this device connects to this switch. Based on the DELC, it knows which circuit. Okay? So this one is irrelevant to this one. I mean, they connect to the same circuit, but they have local significance. The same way here, they would create a DELC here to connect to this circuit. Now in the labs and work that we do, we'll call like this red one here, we'll call it 102, and over here they'll call it 201. But the key thing is they have local significance, they're connecting to the circuit. Alright. Again, it's a packet switched network. And if you're wondering, here we have 5 megs, 5 megs, 10 megs. So that is the local loop. Okay, that is what they're paying for to connect it into the cloud. Once they're in the cloud, they're going to get a committed information rate. Okay, and that's what they pay for. They get a committed information rate, and then they can have a committed burst and an excess burst. That's an E. You can have an excess burst. So how that works, if you look at this scenario, if both of these, if here and here were communicating at full bandwidth coming through, so if each of these circuits were 5, they could commute here because this one has 10 divided up between those. It can receive 10 here coming into the router. What you would probably do is your committed information rate would be lower than that. It might be 3 million bits per second to save money, and you would assume these wouldn't be functioning full speed back and forth to here all of the time. So this would be guaranteed. You would save in cost, and then you're able to have a committed burst. You could burst over that a certain amount without the risk of having packets dropped in the network. And then there's an excess burst. When you get over that, it has to do with how it managed the traffic inside the connection. So let's take a look at that more specifically. The biggest important point here, I would say, is the fact that you can pay for less bandwidth in there, but still have good performance because of the burstiness of traffic nowadays. All right. So what we create in there are virtual circuits. We have switch virtual circuits, you know, in which we set up the circuit, tear down the circuit, have the traffic travel. Permanent virtual circuits are up, or appear to be up, all the time. Again, they're virtual circuits. Remember, it's packet switched through the cloud. So we use a DELC to identify it. It has local significance. We have a certain protocol for the local management interface. That's to get into the frame relay switch. Once it's in the cloud, your service provider takes care of the frame relay. You purchase a committed information rate, and then there's these rules on bursting, which we'll talk more about specifically later on. We have a committed burst, and then we have an excess burst. Depending on how busy the traffic is in the cloud, okay, because you're not the only one using the cloud. There are lots of people connected in, different companies connected in your company, so lots of people can be using that frame relay cloud. Inside the frame relay, the address part, the encapsulation, what frame relay puts on there, is it marks these bits. This is discard eligible, so when the traffic gets up a certain point, like you're getting up above your committed rates, it can mark that bit, which means any frame relay switch in the path can drop it. When the traffic gets busy, it can do a forward explicit congestion notification. So we can send that information on a packet that's going forward, and also if there's congestion, we can send it on a packet backwards, explicit congestion notification, which then can tell the device on this end to slow down. Because if the congestion exists, these get marked and packets get dropped, and then if it's UDP, you never see them again. If it's TCP, you have to resend them. Well, that's a little introduction to frame relay.